Greetings to respected Madam Sir. My name is Pavan Sai. I'm from CSC AIML's Section C, and from the course of Probability and Statistics. My topic is Hidden Markov Models for Predictive Maintenance of Convey Belt Systems. So, I'll be explaining how hidden Markov models help predict the hidden health states of conveying by observing measurable signals. So, this is my presentations format. First, I'll be starting with my abstract and the problem statement, and introduction, requirements, prerequisites, technologies used, and the literature reviews, and the methodology and result and discussion, conclusion, and future scope. Let's begin with the abstract. So, abstract in the abstract, the conveying belt systems are essential in industries operations where continuous materials handling is required due to consistent usage. Belt undergoes mechanical wear, misalignment, heat buildup, and vibration related issues. Unplanned failures causes expensive downtime and safety risks. This process use HMMS, hidden Markov models, which are used to analyze the sensors, vibrations, temperatures, current, belt tension, and predict the hidden health states of the conveyor systems. So, modern industries use conveyors for material handling, and the failures causes downtime, safety risk, and financial loss of the company. So, we need to predict management by predicting faulty before the occur. Hidden Markov models HMM is a useful statistical tool for this. So I'll be explaining how hidden Markov models help predict and hide health states of the conveyor by obeying measurable signals. So the object is to detect degradation early and enable predictive maintenance through probabilistic modeling. The problem statement. So, first I'll be explaining what an HMM is. So, in very simple explanation, HMM is a statistical model in which it has hidden states, observations, and transition probabilities. So, in the hidden states, not only directly visible, but I can give some examples: healthy, warning, faulty. In the observations, measurable signals are like vibrations, temperature, and the sound. And transitional properties change chance of moving from one state to another state. So, speaking of HMM models, machines like a system that switch between hidden health states, and we try to empathize them by using observable sensor data. So, coming to the problem statement, to develop a HMM based predictive management system, I mean maintenance system, that can classify conveyor belt health into hidden states, healthy, degrading, and faulty using observable data sensors. So the challenge is to model degradation pattern that are not directly visible, but they can be inferred from fluctuation in sensors. The goal is to build a system that accurately predicts state transition and provides early warning before mechanical failure. So why is HMM for conveyors? Conveyors health is not directly visible, which is in the form of hidden state. Sensors gives noise data, which are through observations. So where increase gradually, probabilistic transitions, HMM can predict future states and warn HMM before failure. Um, they There are some hidden states examples. So first one is as healthy normal operation warning. Uh, Warning is like belt wearing, mild vibrations, high variable um, high variable future states which form before failure. So the goal is to build a system that accurately predicts states transition and provides early warning before mechanical failure occurs. So the introduction, Conveyor belts play a vital role in manufacturing, mining, logistic, and automated production lines. Their performance affects the overall efficiency of the industrial process. So the transitional maintenance methods are either reactive, fixed after failure, preventive, performing maintenance at fixed intervals. However, both approaches are inefficient because they do not account for real time equipment conditions, and the conveyor health is not directly visible. Hidden states. Sensors get noisy data observations where increase gradually probabilistic transitions. HMM can predict future states and warn before failure. So, hidden states examples are like healthy, warning, and faulty. Healthy is like, I'll be giving the meaning of it. Normal operations, and for the warning, it's belt wear and mild vibration, and for faulty, high vibration, possible breakdown. Um, uh, the conveyor belt plays a vital role in manufacturing, mining, logistic, and automated product lines. Their performance affects the overall efficiency of the industrial process. So, the transitional maintenance methods are either reactive or preventive. The reactive methods are fixing after failure, and the preventive maintenance methods are like performing maintenance at fixed intervals. However, both approaches are inefficient because they do not account for real time equipment conditions. Predictive maintenance combined with HMM, hidden Markov models, enabling intelligence monitoring by modeling hidden degradation states based on observation data patterns. And the requirements availability of historical and real-time sensors data, vibrations, temperature, current, belt tension, understanding of statistical modeling and time series analysis, tools for implementing HMM algorithms, adequate pre-processing to remove noisy from sensor data, and the visibility visualization to represent states transitions. And the key probability conditions are like transition probability, emission probability, and initial probability. And for the transitional probability, we can take the symbol as capital A, and for the emission probability, we can take capital B, and initial probability as pi. So the first transitional probability, P, health gives warning, P, warning gives faulty. For the emission probability, P of vibration equals to high or state equals to warning. Initial probability that conveys starting in a healthy state. And the algorithms we use are forward algorithms, Vibri algorithm, and bomb like training. So I'll be talking about the algorithms later. So the prerequisites are the knowledge of probability Markov chain and statistic processing, understanding of machine learning basics, familiar with failure models of conveying belts, programming skills with preferable Python, understanding of Viterbi and Baum-Welk algorithm. So the predictive maintenance output are HMM predictive, current state health, product probability of entering a faulty state soon, remaining useful life RUL, early warning, example failure like in 5 hours. The simple example is if vibration is increased, HMM changes the state from healthy to warning to faulty. It triggers maintenance before breakdown, reduces downtime and cost. And the real world benefits are prevent unexpected conveyor stoppage, improves work safety, save maintenance cost, and optimize spare part planning, increase machine lifespan. And the technologies used are Python for implementation. Libraries are NumPy, Pandas, Himlean, and Matplotlib. And Graphiz for HMM state diagrams, Jupyter Notebook for analysis and visualization, IoT devices and industrial sensors for real-time development. So the key probability and the observations, the sensors provide data such as vibration amplitudes, temperature, motor currents, and sound leveling. Why HMM for conveyors? Conveyors health is not directly visible, hidden state. Sensors give noisy data which is in observations, where increase gradually. Probabilistic transition. HMM can predict future states and warn before failure. In the literature review, Rabiner of from the year 1989, Foundation research on the hidden Markov models, studies on vibration based faulty detection, um, in industrial equipment, research on conveying belt failures, um, diagnose, diagnosis using machine learning and sensor data. Industrial case studies use HMM and predictive maintenance, modern predictive maintenance solutions for Siemens, ABB, Honeywell. And the methodology, collect raw sensors reading from conveying belt systems, pre processed data, filter noises, normalization signals, uh, define hidden state representing degradation states, train HMM using bomb Wilch algorithm, estimate most probable state sequence using Viterbi decoding, and analyze transition probabilities to predict potential failures, generate alerts when probability of the faulty sensors, faulty states is high, visualize the state change over time for better interpretability. The results in the discussion achieved in the percentage of 85 to 92 accuracy in identified health state, faulty predicted from 2 to 6 hours before breakdown, smooth visualization of the transitions for health degradation for faulty, and the modern show strong resilience to the sensor noise. Discussion, HMM provides insights into hidden degradation patterns using useful even with noisy or incomplete sensor data, demonstrate practical benefits for industrial users, conveying systems. Future performance depends on data availability and sensor reliability. In the conclusion, hidden Markov models are efficient for modeling hidden deterioration in conveying systems. They enable early detection of faulty, reduce downtime, and support predictive maintenance. HMMs are suitable for real-time monitoring and integrate well with industrial IoT infrastructures. Future scopes, hybrid models using combining HMMs with deep learning, LSTM, HMM, integrated with cloud dashboards for live monitoring, edge development on industrial microcontrollers, predicting remaining useful life like RUL using advanced analytics, expanding to other rotating machinery and industrial equipment. And I want to conclude my presentation with this. Thank you.